And now we're going to do subtracting rational expressions. Much like adding rational expressions, you start with a fraction such as 3 over 4 minus 5 over 4. The denominators are the same, so you simply look at the numerators. 3 minus 5 gives you negative 2. The denominator stays the same over 4. You reduce it to negative 1 over 2. Always check to make sure you reduce your fractions. The next example we'll look at will be 20 over 23 minus 4x over 23. Again, since the denominators are the same, you simply combine the numerators. Remember, since you're subtracting, that other numerator is negative. It'll be over 23. This one so happens I can factor the numerator. So I look at 24. The GCF I can take out as 4. The remaining factors are 5 and negative x, and that will be over 23. If that 23 were something that could be divided by 4, I could simplify that even further. In our next example, we'll still have a common denominator, but we'll look at what happens when we have more complex numerators. This time, since the denominators are the same, I want you to focus on what happens to that second numerator. I combine them, but since this is a group, I have to make sure that I keep it a group. The negative outside is distributed, so it changes the sign of both terms. So now I have x plus 2 minus x minus 1. Again, denominator does not change. Now I can combine like terms. I have an x and a negative x, so that gives me 0. I have 2 minus 1, which gives me 1. So my answer will be 1 over x minus 4. Can't be reduced. Nothing else can be factored. It's simplified. Let's take a look at when I have different denominators. I'm sorry this got cut off at the top. I didn't realize that until later. Apparently, 5 and 6, the denominator that's common between them, you actually have to multiply them together. And remember that you have to multiply by 6 with the 5, because that's how you get to 30. And when you multiply the numerator, you get 18, so it must have been 3. On this one, you multiply by 5 in the numerator and denominator, and when you do that, you get 25. So it must have been 5. Sorry, an added problem in there. Again, when you simplify the numerators, you get negative 7. The denominator stays the same because you made it a common denominator. In this next example, we're looking at a fraction that is over 2x, and the other fraction that's being subtracted is over 4x squared. Here you have to get a common denominator, and so you look at what factors are not in both fractions. Sort of like with the 5 and 6, you had to multiply them together because there wasn't a 5 and a 6 in both of them. Here we have a 2 and an x, 4x squared. So it's 2 times x and then 2 times 2, x times x. So the only thing that's missing from the 2x is 2x. 4x squared has it all. So now I'm going to change my denominator to 4x squared, but I have to change the appearance of that numerator. Remember, here, nothing needs to happen. It stays the same. So I'm going to multiply the numerator by 2x. And when I do that, I have to keep in mind that 5x minus 1 is a group. So I have to use the distributive property. When I do that, I will get 10x squared minus 2x. But remember, that big minus sign in the middle means that that 3 is actually a negative 3. Now this I'll rewrite over, sorry, so that you'll be able to see it. There was no GCF in that, and it didn't need to be factored, or it couldn't be factored. So let's take a look at another example where we have binomials and their denominators. X minus 2 and x plus 2. What's missing from these two? Well, the other factor. We don't know what these numbers are, so we have to include both of them and multiply them together, just like we multiplied the 5 and the 6. It just so happens that now it's x minus 2 and x plus 2. Since I multiplied the bottom by x plus 2, I have to multiply the top by what's missing, which is x plus 2. Again, in the other fraction, what's missing? The x plus 2 is there already, so it's the x minus 2 that I multiply in the top and the bottom. You can even see in the way that they're written that x plus 2 over x plus 2 will give you 1. X minus 2 over x minus 2 will also give you 1. Now you should be able to tell the distributive property was used. Again, I've simplified this already, so I distributed that 3 and then left the minus sign on the outside. So it's 3x minus 6 because I distributed 3 times x and 3 times negative 2. Now we're going to take a look at what happens when we distribute that negative. And I know someone out there is thinking, what if we just multiplied by negative 3? You could have done that and that would have been fine. Just make sure you change the sign. See, there's a negative 3x and a positive 6. Now I'll combine like terms. 5x minus 3x gives me 2x. 10 plus 6 gives me 16. I'm going to keep the same denominator for right now because I want to see if I can factor out one of those and divide out a common factor from the top. As you can see, that 2x plus 16, that will factor. I can take out a 2 and get x minus 8. Wouldn't it have been really nice if that had actually been x minus 2 or x plus 2? Because then I could divide it. Some textbooks, you might see them to multiply that denominator back out. But here we won't. So if it says x squared minus 4 in the back, then no, you're still correct. All right, well, that's subtracting rational expressions.